Morning Auto 2. We're going to be beginning talking about ignition system today, and we're going to be looking at the purpose of ignition system first. I'm kind of going to give you an overview of the ignition system. In Auto 1, ideally I would have gotten to ignition system, but I didn't. And so this may be a first go at it for many of you. So here's a set of spark plugs with all different kinds and conditions. And obviously the main purpose of an ignition system is to ignite or create a spark that's going to thoroughly ignite the air-fuel mixture to do these three things: maximize power, which is our teenager desire, maximize economy, which is your parents' desire, and minimize emissions, which hopefully is all of our desire. But anyways, I want to remind you, as I'm going through this, I'm going to speak rather quickly. As you watch the video, you can put your speed on 0.75 by clicking on the little gear down in the right-hand corner of the video. So you can change the speed, or you can pause, or whatever. So here's a simple old school ignition system here with an electronic distributor. Here's what we call a distributorless or coil pack ignition. And those will be back several generations now. But in any case, we want to thoroughly ignite the air-fuel mixture, which at sea level, the stoichiometric air-fuel mixture is approximately 15:1 for ideal for power, for economy, for emissions. If we want more power, we typically go richer. If we want more economy, we typically go leaner. And to minimize emissions, we stay in a happy balance between rich and lean. Okay, so a basic ignition system is going to jump up battery voltage, or once the car is running, charging system voltage from approximately 14 volts to as much as 15,000 volts. And that's kind of an average. Most cars idle at about 10,000 volts. Under load, going up to grade, you might see 30, 40,000 volts. So you've got a 12-volt battery, and again, obviously, charging system voltage when the car is running would be about 14. The ignition coil is a step-up transformer. This is an old school picture showing one coil for all cylinders. Some sort of switching device to turn this transformer on and off, and we'll talk about why. But we're going to boost the voltage up to be able to jump that gap. And that gap is difficult to jump, not only because of its distance, which is on average between 30 and 60 thousandths of an inch. That's not a very big gap. But cylinder pressure, air-fuel ratio, etc., will also make it very hard for the spark to jump the gap. So the general function of an ignition system is we're going to turn this spark ignition engine on and off. Now, that was more true in old school cars. Today, when you shut the key off, we're turning the coil off. We're also turning the fuel pump off. We're also turning the computer off, etc. So secondly, we're going to operate on either battery voltage when we're cranking or alternator voltage when we're running. We're going to convert 12 volts to a high voltage arc at the spark plug. And again, I say 12 volts generically, but just remember when the engine's running, it's approximately 14 volts. And we're going to distribute the spark to each cylinder in the correct sequence and at the right time. So the right time, here's my piston. I go down on intake, I go up on compression, and I go down on power. Now the spark has to occur before the power stroke starts, obviously. But in reality, we have to start the spark typically at idle, about 10 degrees before we get to top dead center. So just before, because it takes time for the explosion to sort of expand and get ready to push. The faster the engine spins, the earlier we have to make the spark occur. Here's an old school distributor system with a distributor cap, 8 spark plugs, ignition key, a ballast resistor, a single coil, and a distributor with points. This was all gone by the mid-late 70s, okay? But that is a basic old school ignition system. And so when we distribute the spark to each plug in the correct sequence, we call it the firing order. So which cylinder is at the end of its compression stroke and needs a spark, and exactly when we do it, it would be timing, okay? So we would say time. So yes to number one spark plug as an example, but exactly how many degrees before top dead center is the timing. How a spark is made. So current flow through a coil of wire produces magnetism. And you've got a picture of an automotive coil there, and here's the insides of part of a coil. This is the primary wrapping of wire. If I put current through this insulated, and this is insulated, it's plastic coated. If I put current through this coil of wire, I'm going to produce magnetism, and we call it an electromagnet. And if I rapidly shut off the current flow through this coil, the magnetic field collapses, and it collapses out through air. And if I have an adjacent coil, this one here is the secondary, which is actually down the center, because it both collapses out and in, I'll get a big surge in that adjacent coil. So it says a second adjacent coil will receive an induced high voltage current surge. Induced means to put into. So this guy, if I put current through this and I shut it off, the magnetism causes a high voltage boost in this second coil. And the boost is dependent on the numbers of windings. So this is a few hundred turns of, the primary winding is a few hundred turns of about 20 gauge wire, 18 gauge wire. And this is several thousand turns of a super fine wire. I'm going to go up to the camera, and I don't even know if you can see it. It's like hair. So it's super, super fine. And I know I can't see it in the camera. So here we go. So this is what we call coil action. This turning on the electric current flow through the primary windings of the coil, shutting that off, which causes a high voltage induction into the secondary winding, causing a boosting effect in the voltage, is what we call coil action. The transformers on the power poles in your neighborhood, those are step-down transformers. I believe they step down from approximately 4,000 volts to 110 volts. All houses have two 110-volt lines going to them. If you need 220, which most houses do, it's not for some device like an electric dryer or maybe an oven or something, or maybe a hot tub. We combine those two 110-volt wires, or in the electrical world we call them legs, with a special breaker on the panel. So there's two circuits to an ignition system. There's what's called the primary circuit, and there's what's called the secondary circuit. And the primary circuit is all those low voltage components in the ignition system. So you should see a picture here in just a moment. So all parts carrying battery or charging system voltage, the battery, the ignition switch and wiring, coil primary windings, which I already showed you here once again, a switching device. So now if you look at the picture, primary circuit is all the low voltage carrying components. So the battery or alternator, ignition switch, whether it's a key start or push button. Older cars have what's called a ballast resistor, some sort of switching device to turn the current flow through the primary windings of the coil on and off. This picture is not very accurate because it's only showing 3 loops, and there's actually several hundred in the primary winding. That's the primary side of the ignition system, all the low voltage components. Here's the secondary side. Secondary is the high voltage side. So I say 7 kV, 7,000 volts to 30,000 volts. Can go higher, usually not lower. So that secondary is all the parts carrying high voltage. So the coil secondary windings, the guy I showed you here, okay, the hair-like wire. Cap and rotor, I'm going to show you this in the picture. If we have a distributor type system, it's got a cap and rotor. And then plug wires and plugs. So all cars have spark plugs, no matter what the type of system. The only cars that don't are diesels. Distributor with a cap and a rotor that spins and distributes the spark from the center coil terminal to each one of these in the correct firing order. Well, this is old school cars. We got rid of distributor and cap and rotor on GM passenger cars in the late 80s. And you know, Honda's always last one to change everything. Honda changed their away from a distributor on their Civics. I believe I think the last year for the distributor was 2000. I think 2001 is a coil on plug. And this is a single coil, and all cars today have either one coil pack, which is a group of 2 or 3 coils, or they have individual coils per cylinder. That's the secondary circuit. So I'm going to talk about types of systems really quick. And the first one is a point type system that we had until approximately the late 70s, where you had a battery and an ignition switch that sent power through the primary windings, making a magnetic field through these little contact points to ground. This is a spinning shaft inside the distributor. When it pushes on that rubbing block, it opens the points, which breaks the contact to ground. which stops the current flow, which causes a magnetic field collapse and a high voltage surge that goes over to the spark plugs here. That's a point type system. I'll grab a set of points and show you here in a sec. So here's a set of ignition points. These little guys, I think I can make it so you can see them in the camera. So when this would open like that, that would break contact to ground or provide contact to ground. So here's a point type distributor. And hopefully you can see those points. I don't know if I have enough light there. So as this guy turns around, you'll notice the little point right there is going to open. So there it opens right there and closes and opens. And I'll show you what it's touching. It's touching right there. Let me see if you can see it with the light. Not as easy as you think to do this. Hopefully you can see where that thing's rubbing right on that distributor cam. So this cam has several points. So each tip or point on that, we call it a distributor cam, as you see it spinning, is the number of cylinders. This is an 8-cylinder, so there's 8 of those evenly spaced around the circumference of the shaft of that distributor. So that was till the 1970s. So if I can get this thing to advance, there we go. So in 1974, approximately to the 80s, we went to what's called electronic ignition. We still had a single coil firing all the cylinders, still got spark plugs, still got a battery ignition switch. But instead of have those rubbing, contacting points, which every time they would open, they would arc and they would burn the faces of those points. So these little faces down in here would get burned every time they open and then they close and then they open. You get an arcing there. So that became a high failure rate, and we wanted to improve emissions. So we wanted to get ignition more stable and consistent. So we figured out we could come up with what we call a magnetic pickup with a transistor, which is a fully electronic on-off switch. And we could, with these two together, we can turn on and off that coil primary circuit much more quickly, and which causes a hotter spark, and much more dependably too. In the early 80s to late 80s, we came up with computerized electronic ignition. Still had a distributor similar to what you had, but now we had a computer involved. So the computer is going to say, okay, given this throttle angle, the vehicle speed, gear shift selection, the amount of load against the vehicle, I want 42 degrees before top dead center. So the computer is involved in adjusting when the timing occurs, and you're no longer able to adjust it at this point. You're not supposed to. So here's kind of a summary. Point type until the 70s, electronic ignition into the 80s, computerized ignition early 80s to late 80s, and then the next system is the DIS. The DIS is also known as a waste spark system or a coil pack ignition. So there's a picture of a coil pack. It's actually a coil here firing these 2 cylinders and a coil here firing these 2 cylinders. I'll grab one sec. So here's a coil pack. This is a GM coil pack for a 6-cylinder, 1, 2, 3 coils, each one firing 2 cylinders at the same time. This way we get rid of a distributor. There's no more rotating distributor. Ignition is able to be stronger spark because now each coil is only firing 2 cylinders instead of one coil firing 6. And this was all the way up till, when I say till present, not till 2020, but pretty modern. Cars to 2010, 2012 still had, some of them still had DIS or coil pack ignition. So here's a picture of it. Again, there's 2 coils for a 4-cylinder, each firing 2 cylinders at the same time. It says one plug fires on the compression stroke and the other fires on the exhaust stroke. Give me 1 second here. So what you're seeing in the picture is a DIS or waste spark ignition system. And it's showing that the way the secondary winding is run, this is the primary winding here. Remember, it's heavy turns of a few hundred turns of heavy wire, and this is several thousand turns of fine wire. The picture's not accurate because they're showing the same thickness of line and the same numbers of loops, but the secondary is wired to one plug and then over to the other plug. So when it fires, when it gets the high voltage surge, we jump from center to side electrode, make a spark. We also jump opposite polarity side to center electrode and get a spark. This cylinder is on compression, this cylinder is on exhaust. The exhaust spark does nothing. It serves no purpose other than the simplicity of wiring and having one coil firing 2 plugs. These are what we call companion cylinders. When this one comes up on compression, this one's going to be on exhaust. Okay, so let's keep going here. So here's our systems again, just point type, electronic ignition, computerized with distributor, DIS. And the last system we want to look at is coil over plug or coil on plug, COP, or direct ignition is other names for it. But we just call it coil on plug or coil over plug. And it looks like this. So direct ignition or coil on plug. We have an ignition coil mounted over each spark plug. There's no spark plug wire. The plugs are only fired at the end of the compression stroke, and plugs do not fire in the exhaust stroke. So this would be a 4-cylinder, and you've got 4 coils, and this would look like this. So here's one coil on plug coil, and it just snaps right down on the spark plug, and it's got some primary wires going to it. This thing's a little ignition transformer, just ups our 14 volts from the charging system to 10,000 volts or whatever we need to fire the spark depending on the need at the moment. Okay, so, and it's just showing not a very good picture, but this is down underneath the valve cover, just showing a coil straight on a spark plug. So general ignition system components. Every system obviously has a battery or an alternator. Every system has an ignition switch, whether it's a key start or a push button. Every system is going to have, let's see what's next, ignition coil, at least one, or maybe one for every 2 cylinders, or maybe one for each cylinder. And then we have to have some sort of triggering device. That is some sort of device that's going to turn on and off that coil primary current. So it used to be ignition points that I showed you. Now we use a little box called an igniter or an ignition module. And so then we have, there's 2 devices, and I actually just misspoke. A triggering device is the device that sends a little signal to the transistor in the ignition module. The ignition module is the switching device that turns on and off the primary winding ignition current. The triggering device tells it when to do that, basically. Okay. And if we can get this thing to go forward, and then we've got spark plugs. And then we have spark plug wires. Some cars, not all cars have spark plug wires. If it's coil on plug, we don't have plug wires anymore. And that's it for our general overview. We'll talk about these things specifically in our next lecture.